Okay, for this problem, it says a student states that given any two sets, A and B, either A is a subset of B or B is a subset of A, what assumptions might the student be making? And so when you think about the definition of subset, it's a set within a set. And so there are elements that those two sets have in common. So if the student is assuming, well, either A is a subset of B or B is a subset of A, there are some assumptions they might be making. Now, A says the student might be assuming that they have the same cardinality, and that does not make sense because cardinality means that they have the exact same number of elements. And when you're considering subsets, you usually will consider that it's a set within a set, meaning that one of those sets generally has less elements than the other one, making them not have the same cardinality. I'm going to skip to C. The student might be assuming that they're finite. Well, finite just means that they don't have an infinite number of elements in them. And so assuming that they're finite, really, that doesn't give you any clue or indication that they're subsets of each other. D also saying that they're complements. So if like you have a set A and B and they're complements of each other, if you have set A, then if they were complements, B would be everything not in A. And complements are not ever sets within each other. If you think about when we did in the notes, like, okay, here's everybody that lives in Lubbock, and then L complement is everybody that does not live in Lubbock. Those are two separate sets, definitely not subsets of each other, because complements, they don't ever intersect each other. And so going back to B, the student might be assuming that A or B is the universal set. That makes sense because if A is the universal set, then B could be a subset within it. Or if B is the universal set being that big box, and then set A would be, like a circle within that. So like, let's say that A, I'll just say A, for example, is the universal set of everyone who lives in Texas. And then B is inside of that, a circle inside of that, everyone who lives in Lubbock. B would be a subset of A. And you could do that vice versa. Let's say B is the universal set of all the students that attend SPC. And A is the set of everyone in 1350. Well, set A would be a subset of set B. And so when you assume that either one of those are the universal sets, it makes sense that the other could be a subset of that. And that one definitely is a bit more challenging. It just really pushes you to make sure you know your vocabulary of, what are complements really? What does finite mean? Finite means it's not infinite. What is the universal set? What is cardinality? Makes you push to learn those definitions. The other question is that third grader asks whether infinite sets can be compared. Infinite sets meaning there's an infinite number of elements inside of them. And so like the set goes on and on forever. You can think of that as, you could even look at it as like numbers. Like, okay, this set starts with the number 1 and it goes on infinitely because numbers do go on infinitely. So these sets have an infinite number of elements to them. Can they be compared? And so when you look at the elements, or when you look at the answers, they can be compared as long as there is a one-to-one correspondence mapping between them. Now, right here, I kind of want to make sure that you kind of understand, and definitely this is, a more challenging question, and you might want to go look up, what one-to-one correspondence is, because if you go look that up, you're going to get some really good visuals, and that will be a good thing for you to do on your own. But if we look at these other answers like A, infinite sets can be compared infinite sets are equal as long as it is possible to find a one-to-one correspondence between them. Just because there's a one-to-one correspondence between them does not at all mean that they're equal. It means they are equivalent. And I want you to think back to your notes. Like if we had this set of 1, 2, 3 and A, B, C, there's a one-to-one correspondence between them. That doesn't make them equal. It makes them equivalent. So that definitely throws out A. And then B and D are obviously wrong because it says, they can't be compared. B saying infinite sets cannot be compared. All infinite sets are subsets of other infinite sets. So the comparison is not meaningful. And that is not necessarily true. All infinite sets are not necessarily a subset of another infinite set. And infinite sets have infinite cardinality for part D, and the concept of one-to-one correspondence cannot be applied to them. The concept of one-to-one correspondence can be applied to them, so that does make them equivalent, which means they, yes, can be compared. And that question is, definitely more challenging. It pushes you into higher level of thinking. So I don't want you to be, discouraged like that was a weird question, because it is a weird question. But again, I encourage you to look up vocabulary words, like what does infinite mean? What is one-to-one correspondence? What are subsets? What is infinite cardinality? Just making sure you really have down the vocabulary for that problem. And then I think that the answer, by eliminating other answers even, will make sense. So I hope this video helped you. Let me know if you still have questions.